So here we are gonna trace a parabola y equal to x square by using the characteristics of curve tracing that we have learned. So guys, to trace the parabola or to understand the shape of the parabola, I'll start with the first property which I've taught you, that is the point of intersection, and that will see the critical point, and then by using that we will trace the parabola. Now guys, I told you that there are 6-7 properties that we are gonna learn in tracing the Cartesian curves. So whenever we have any curve, we can trace that curve by multiple characteristics. So it is possible to trace the parabola by using some other properties as well. So you can use any method to trace the parabola, but use the method which is shortest and which can give you the quickest answer. So guys, right now as I've taught you only 2 characteristics of parabola, I will be using those 2 characteristics to understand the shape of the parabola. So let's start. So first characteristics that we have seen is point of intersection with coordinate axis. So let's find out point of intersection with coordinate axis, for which I taught you we have to put x equal to 0 and find out the value of y. So let's put x as 0. So by putting x equal to 0, 0 square will be 0, y will be 0. And then we put y as 0 to get the value of x. But when you put y as 0, your x will be 0. It means you will get the same point. So guys, this is the point of intersection with coordinate axis. So this curve, that is the parabola, is gonna intersect the coordinate axis at 0, 0. Second, let's see the critical point. So how do we get the critical point? So for critical point, we find out the value of first derivative of the curve. So your curve is y equal to x square. So I'll find out the value of f dash of x, and that is nothing but 2x. So I told you the definition that critical point x equal to c is such a point at which the value of f dash of c is either 0 or does not exist. So guys, can you tell me the point C at which this curve will be 0 or does not exist? Yes, that point is 0. So at x equal to 0, this will become 0. So that is f dash of 0 is becoming 0. So I can say that x equal to 0 is my critical point, because at this point I am getting the value of f dash of x as 0. Now if we put x as infinity, then we'll get the answer as infinity. So x equal to infinity can also be a critical point, but since x equal to infinity is again an infinite point, we will not consider it over here. So right now we'll say that x equal to 0 is our critical point. Now guys, based on the critical point, how should we draw the curve? So let's see that. So let's revise the concept that we have done. So in the critical point, we have seen that between any 2 critical points, we understand the nature of the curve. So to understand the nature of the curve, we require 2 points. But here in our case, we just got 1 critical point. So here I'll write it down. Let's say the first critical point that we got is 0. So what we'll do is, to understand the nature, I'll consider other 2 points as infinity and negative infinity. So here between this first region, that is 0 to infinity, I'll understand the nature of the curve, and similarly in the second region we'll see the nature or the shape of the curve. So the first region, that is 0 to infinity, here I'll write 0, or first of all less than x less than infinity, and for second region here we'll write negative infinity, x and 0. Now to see the nature of the curve or the shape of the curve between the point 0 to infinity, we will find out the value of f dash of some point A. Now what should be that point A? So you can consider any point. So here I'll consider that point as 1. So I'll find out the value of f dash of 1. At the same time, we'll find out the value of f double dash of 1. And based on that, we'll decide whether the curve is concave upwards or downwards or increasing or decreasing. So let's find out f dash of 1. So I'll put that 1 here. So f dash of 1 will be 2 into 1, that is 2. And to get f double dash of 1, we have to find out the value of f double dash of x here. So that is equal to 2. So when we'll put 1 here we have constant, so answer will be 2 itself. So guys, it means here we are getting the value greater than 0, as well as this value is also greater than 0. So now let's draw the curve parallelly. So let's say this is x and y axis, and this is the point 0, 0, which is our point of intersection. Now let's say that this is infinity and this is negative infinity, and this point is 0. So since the value of f dash of 1 and f double dash of 1 both are greater than 0, we'll see our cases. So according to it, whenever both derivatives are greater than 0, we say that the curve is increasing and concave upwards. So our curve will have shape like this. So guys, let's come here. Our curve is increasing and concave upwards. So increasing means from 0 to infinity it will increase, and concave upwards. Also, it is said that the point of intersection is 0, 0. It means whenever it is increasing, this end we don't know, it will extend till infinity, but the other end will meet at 0, 0. So here our curve will look like this. So I got the curve or the nature of curve in 0 and infinity, between 0 and infinity. Now let's learn, or let's find out the nature or the shape of the curve between minus infinity to 0, and for that we have to consider another point A. So here I have considered that point as 1, so here we'll consider as negative 1. So for that we'll find out f dash of negative 1 and f double dash of negative 1. So f dash of minus 1 will give us minus 2, which is less than 0, and f double dash of minus 1 will give us 2 only, which is greater than 0. So first derivative is less than 0 means curve is decreasing, and the second derivative is greater than 0 means curve is concave upwards. So decreasing means from minus infinity to 0, our curve or the shape will decrease and it will be concave upwards. So this is negative infinity, this is 0, so it is decreasing, so it will come down from minus infinity to 0, and it will intersect at 0, 0, because that is our point of intersection. So it will look like this. So guys, this is decreasing and concave upwards. So here we got the shape of parabola. So you must have understood that how this parabola will look like. So curve tracing gives us the rough idea about the shape of the curve and where that curve will intersect the x and y axis. So guys, this is the first parabola. Now we'll see the another parabola. We'll trace another parabola. So here I have equation y equal to 4x minus x square, and for this again we'll follow the two-step process. So step number 1, we'll check the point of intersection. So guys, here for that we'll first put x as 0. So when we'll put x as 0, we will get y as 0, and then we'll put y as 0. So when we put y as 0, see here we will get like this: 0 equal to 4x minus x square, or I would say 0 equal to x into 4 minus x, which will give us x as 0 or x as 4. So guys, here we are getting x as 0. So if I put x 0, here I'll get 0, 0, but we have already covered that point over here. So I'll take second value of x, that is 4. So here we will get 4, 0. So guys, it means the point of intersection for this parabola is 0, 0 and 4, 0. Now let's see the second characteristics. So second characteristic is critical point. So guys, we are gonna find a critical point for this given curve, and based on the critical point we are gonna see the shape of the curve. So for critical point, we know the condition that the value of f dash of x must be 0 or does not exist. So for that we'll find the derivative. So derivative of 4x is 4 minus 2x, and at the same time I'll find out the value of f double dash of x to learn the shape of the curve. So derivative of 4 is 0 and here we will get minus 2. Now guys, to get the critical point the value must be 0. So can you tell me the point at which the value of f dash of x will be 0? Yes, so that point is 2. So when x is 2, this will be 4 minus 4, that is 0. So here I'll say that x equal to 2 is critical point. So guys, it's very easy. Whenever you want to find out a critical point, just do one thing. Take that value of f dash of x and equate it to 0. So this will give us 4 minus 2x equal to 0, or 4 equal to 2x and x equal to 2. And whatever is the value of x that you are getting is your critical point. So x equal to 2 is the critical point. Now based on the critical point we have to draw the shape. So to draw the shape of the given curve, what we'll do is we will consider the range, and in the range we will take the two critical points, because we have seen a concept where to learn or to understand the shape of the curve we want the two critical points. Now here in our case we got only one critical point, that is 2. So we don't know the other critical point. So here we'll consider it as infinity and negative infinity. So it means I'm gonna understand the nature of the curve between 2 to infinity and then between minus infinity to 2. So for that, between 2 to infinity we have to consider some point A. So let's say that point is 3. So at 3, let's see what is the value of f dash of x and f double dash of x. So here guys, the between 2 to infinity, the value of f dash of 3 equal to, so this will be 4 minus 6, and that will be minus 2, which is less than 0. And similarly the value of f double dash of 3, so that will be minus 2 itself, which is less than 0. So guys, it means between 2 to infinity we are getting the first derivative as well as the second derivative as less than 0. So let's see our case. So here we have seen that whenever both derivatives are less than 0, that curve is decreasing and concave downwards. So let's draw the curve here. So I'll use the first sheet itself. So this was the curve y equal to x square. Now we are drawing the curve y equal to 4x minus x square. So guys, here first of all let's plot the point of intersection. So here the point of intersection is 0, 0 and 4, 0. So 0, 0 means this point, and 4, 0, let's consider it over here. So this is 4, 0. So let's say this is 1, this is 2 and this is 3. So these are the 2 points of intersection. Now we are finding the nature of the curve between 2 to infinity. So this is the point 2, x equal to 2 till the infinity. Now guys, here the value, both values are less than 0. It means the curve is decreasing and concave downwards. So it will have a behavior like this. So it will be concave downwards. Okay. Now the question is where my curve will intersect. Okay. Because see, my curve is intersecting at 4, 0. It has the nature of concave downwards and decreasing. So it will have shape like this. Okay. So the point is 2. So from 2 to infinity, it is decreasing. But guys, 2 is not my point of intersection. So my point of intersection is 4. Okay. So to get the shape, we will wait for some time and we'll get the shape of the curve between 2 to negative infinity. So let's go for that. So between negative infinity, x and 2, we'll find out the value of f dash of, let's say, I'll take that point as 1. So for 1, we will get 4 minus 2 into 1, that is 2, that is answer is 2, greater than 0, and f double dash of 1 will be minus 2, which is less than 0. So whenever first derivative is greater than 0, it is increasing curve, and second derivative less than 0, that is concave downwards. So guys, in this range, that is negative infinity to 2, it is concave downwards, but it is increasing. So now let's come to the point. So it means, let's say this is the point 2. So between 2 to negative infinity, we are getting increasing. So it is increasing and concave downwards. And guys, understand that curve should go through this point 0, 0. So it means it will have shape like this, something like this. Now between 2 to positive infinity, what we got is the curve is downwards and decreasing. So decreasing means should go down and downwards. So we'll have shape like this, and it should pass through 4, 0 because that is our point of intersection. So our curve will look like this. So guys, here we got the parabola by sketching the curve by using the characteristic. So here we got the general idea about the shape of the parabola, how it will look like, and now based on the shape you may solve the further integration question. So basically in the integration we get such curves which we have to draw, and then we have to solve or evaluate the integration. So here I have told you how to trace this curve, that is the parabola y equal to 4x minus x square, and then you can evaluate the integration. So guys, here I have shown you one method, but this parabola can be traced by using other methods as well, and for that we have to learn the other characteristics. So based on the other characteristics, you may trace this curve by using the other characteristics. So I'm sure that you understood this both parabolas, how to trace a parabola and how to get the general idea or rough shape of that parabola. So we'll meet in the next video where we'll see the other characteristics of tracing of curve and how to trace the different curves. Thank you.